Today's topic is table spaces. So we have seen yesterday that when we create a user, there is a default table space that is assigned to a user, and a table space is basically a area somewhere sitting on the hard disk in which our table goes in. Whatever table we create goes in there. So that is the concept that we're going to talk about. How is the table space laid out? As your DBA career takes off, this is probably the area where you will be spending a whole lot of time about the disk space management and finding out which tables are where, all that stuff. So conceptually, this is a very important discussion. As far as things are to be done, there are mostly monitoring things. So I will tell you, there are things to be remembered, the data dictionary views, then certain basic commands, not too many commands, but monitoring is the most important thing as far as the table spaces are concerned. So we'll start with the concept. How do you create a table? Let us go with that. I think we have gone through this this one. Sorry, create table, T-A-B-L-E. Name of the table is A, and then this is the column which I always say ID is a number, then comma, and then name is let us say char or varchar. We can go with that discussion later, and then maybe semicolon here. This is what we have been doing so far. Now I'm going to add certain other things to that, and I'm going to add things like this. I'm going to say table space TS1. That is the name of the table space there, TS1. And then I'm going to add one more thing called as storage. Storage is initial, let us say 64K. Next is, let us say, 128K, and min extents is 1, max extent is 100, and then a semicolon, then close parenthesis and semicolon. So this is what a table creation syntax is from the DBA's point of view. This is something all of us we know till this point. So what is so different about the part which is below this line? First thing, we are telling that this table should be created in a area on the disk, which is now we are calling as a table space, and the name of that area is TS1. That is a table space in which the table will be created. And then we are specifying what we call as a storage clause. In the storage clause, we are specifying 4 different alternatives. There are many more than that, but these 4 are important, and that is what I'm going to discuss, only these 4. Initial 64 kilobytes, so it's a size. That means when you create my table A, initially reserve 64 kilobytes in this table space TS1 for this table. So the moment the table is created, a 64 kilobytes of area is reserved in that table space for this table. Next is, we will talk about the next little later. As we keep on adding data, the table grows. The table cannot fit into that 64 kilobytes, and therefore more and more rows will have to have more and more disk space. So the next bigger chunk, the next size by which the growth will happen is 128 kilobytes. So when the first 64 kilobytes are filled with all the data for table A, then additional 128 kilobytes will be added or will be reserved for this table A. And then the next, even if that 128 is filled, then the next 128, so all the next extents, we'll talk about, this is the size of what we call as an extent. So I will talk about this word in much more detail. Extent is basically the area that is first allocated for the table. So these initial and the next is something that we have understood. Now I'm going to draw a diagram to make sure that we understand this in a little more detail. So consider that this is your disk space. So this is your disk, hard disk. On this hard disk, so let us say this is your C drive, C colon. Or if it is Unix, then it is, let us say, U01 app, any directory where the data will be kept in, the file. This area on that disk, assume that this is called as TS1. The size of this area, let us say, is 1 gigabyte. So this is that 1 gigabyte area TS1. So this is my table space TS1. Now when I create a table A in my table space TS1, based on the storage clause, the first extent is allocated for that table. So this is the first extent of table A. Okay, extent number 0. Actually, the extent starts from number zeros. 0, 1, 2, 3 or 4. So the size of this extent is 64 kilobyte. Why? Because I have mentioned that. If I had mentioned here 1 megabyte, then it would be 1 megabyte. Depending on whatever has been specified in the storage clause, that would be the size which will be reserved for that table. Now, is there any data in that table right now? No, there is not a single row there, but still that area is reserved for that. So out of 1 gigabyte, let us say 1 megabyte is gone and reserved for that. Okay, that is extent number 0. And then our job is done. That is what the table that is how table gets created. Now in this extent, this is extent number 0. Now I'm going to draw that extent somewhere here. I'm going to blow up the diagram so that we can understand it much better. So this is my hard disk. Now this extent, which looks kind of smaller there, I'm going to draw it as a bigger extent here. So this is that same extent, 1 megabyte size. Now what is inside an extent? Inside an extent, the extent area is divided again into smaller pieces, and those pieces are called as 1, 2. Those pieces are called as blocks. So this is block number 1, block number 2, 3, 4, 5, 6, 7, 8. These are the blocks, and these are called as the database blocks, DB blocks. When a DBA, any user like you and me, creates a database, what is he actually doing? At that time, he is creating nothing but these table spaces. He is creating a table space called as TS1. He is creating a table space called as TS2, TS3, TS4. So he is basically reserving, 1 gigabyte on the hard disk for TS1, and another gigabyte on the hard disk for TS2, and so on and so on. So he is creating those table spaces. And what is the purpose of a table space? To keep tables in it. So first table is here now, which is table A, and now that table's extent is displayed over here. So this is an extent, and within the extent there are these blocks. The size of the block is always decided by the DBA when he creates the database. The size of the block is decided by the DBA when he creates the database. This is a very deciding factor when the database is created, and the sizes range from 2 kilobytes to 4 kilobytes to 8 or 16 and 32. These are the only sizes that a block can have. Okay, nothing in between. There is no block size, database block size over 3K. So Oracle has decided, it has predefined that the database block sizes would be of sizes either 2 or 4 or 8 or 16 or 32. So let us say when the database was created, that DBA decided that his block size should be 8K. At that time when he decides that, how to define all that stuff we'll see later. But he has decided, the block size is 8 kilobytes. So this will be an 8 kilobyte, this will be 8 kilobyte, 8, 8, 8, 8, 8, 8, and total together would be an extent. So now my question, actually, let us go back to our simple example, 64 kilobytes here, and maybe 128 kilobytes here. So this is an extent whose size is 64 kilobytes. If the size of the block is 8 kilobytes, how many 8 kilobyte blocks can fit into this one extent now? 8. So this would be again the first block, the second, again the blocks are going to be 0th block, 1st, 2nd, 3rd, 4th, 5th, 6th and 7th, total 8 blocks. So each block is of 8 kilobytes and there will be 8 blocks like that. If the size of the block was 16, then there would be only 4 of them. Okay. If the size of the block, DB block, was 16 kilobytes, there would be only 4 blocks fitting inside the extent, which is of 64 kilobytes. Why is all this stuff done? First thing is, it's a table space. It's a hard disk. Then there is a table space. Inside the table space, a table is created, and when the table is created, a certain area is allocated, which is called as an extent. And within the extent now, what we are seeing here is there are these database blocks. 1, 2, 3, 4, 5, 6, 7, 8. These are the database blocks. And what is inside the database blocks? That is where the rows are. When we insert any row into a table, that row is sitting inside a database block. Now, our table is what? Table A. Our table was table A. Now our database block size is, assuming that database block size is 8K, 1, 2, 3, 4. I will just name it as 1, 2, 3, 4, so that it would be easy for us to understand. Block number 1, 2, 3, 4, and this is 5, 6, 7, and 8. What is inside this block? There are rows. There are rows inside this block. How many rows can fit in one block? How many rows can fit in one block? It depends on the size of the table. We have a table whose name is A. Okay, what is the length of a row in A? First thing, how many columns are there in A? The first column is the ID. The second column is the name. You have to find out, ID column, how long does it take? Then char column or varchar column, how long does it take? Let us say you said the length of the row is 20 characters. By doing the addition and all that, so length of the row is 20 characters. Then how many 20 character rows can fit into one database block? That is something we can find out. 8K divided by 20 kilobytes, those are the total number of rows that will fit into one block. So now here, why I have asked you to go through this calculation. For the table A, which is a very small, assuming that each row is of let us, for ease of our understanding, each row is of 100 bytes. How do you find it out? By just adding the data types and the lengths there. So each row is of 100 bytes. How many rows can fit into 8K blocks? So 8K is 8096, correct? Divided by 100. So let us say, for ease of 8000 divided by 100. So there would be 80 rows fitting into that one block for table A. If the table was a bigger table, let us say the employee table that we have been going through, it has so many columns, and therefore the length of the row in the employee table would be more than that, more than 100, and therefore less number of rows will fit into one block. Block size will never ever change. Once the database is created, block size is going to be constant for everybody, all the tables. But the size of the row could change depending on the total number of blocks. So now in our example, 100 bytes per row. This is our assumption, it is not correct 100 bytes actually. For our ease of calculation, I have taken it 100. So 100 bytes per row is our assumption. 8000 is the size of the block, and therefore 80 rows will fit into one block. So what really happens when I create a table with this kind of a storage clause in this table space? A extent is created. Within the extent, blocks are already created there, and the first row will get added in the first block. Then you insert one more time, the second row will get added, third row will, likewise 80 rows will get added into the first block, and the first block will be filled. As the first block is filled, Oracle will automatically start inserting data into the second block and the third block and the fourth block. Likewise, as you are inserting more and more rows, it will fill up all the blocks in the first extent. And now I want to still insert some more data. What will happen? There is no space left in the first extent. Oracle will immediately find out, I am going to create another extent, the next extent, and I am going to create that. That means I am going to reserve it within the same table space. The table space is TS1, and the size is going to be 128 kilobytes. Why? Because you have specified so. If I had specified again the next extent to be 64, this would be of the exact same size. 64 again. And in this 64 again, there would be blocks. So the next row, which did not find any space in the first extent, was now added in the second extent's first block. In the second extent's first block. That is what things will start happening. And now you will see so much of space is empty here. So much of space is empty. And all those things are kind of reserved for table A. Now you have created table A, no problem. I am the user whose name is Shekhar. The Shekhar was created in such a way that his default table space was TS1. We have seen that yesterday, how to create a user with a default table space of a specific TS1. Now there is another user whose table space is also TS1. Default table space is also TS1. So that user comes in now. Okay, that user comes in, and now I'm going to draw a diagram here. That our yesterday's diagram. This is my database focus 1. This is user Shekhar. And this is user, now again Manav. Okay, I remember only those two names wrong. So this is Shekhar, this is Manav. Shekhar creates a table A with this specification. Therefore, the first extent of that table A, this is Shekhar's table, is over here. Shekhar has added more and more rows, so the second extent also is created, which is sitting right next to the first extent, and now Shekhar is done with his data loading. Now Manav user comes in, he creates a table called as B. Now when he creates a table B, he specifies different storage parameters but same table space. He specifies 128 kilobytes and here also 128 kilobytes, and therefore, but table space is still the same, and therefore his first extent of 128 kilobytes, maybe it would look a little bigger, that's why I'm drawing it like this, 128 kilobytes is right over here, and within that 128 kilobytes there will be again blocks. So this is the extent of table A from Shekhar, this is another extent of table A from Shekhar, this is the extent of table B, but it is from Manav. So my table's data and your table's data is sitting on the same table space, is sitting right next to each other in a table space, and therefore when I say please back up this one table space, you know why table space is created? Because it is easier to back up. When I say please back up table space TS1, there would be some commands that will be executed to back up that table space, and suddenly what will happen? My table as well as your table as well as anybody else's table in that table space will be automatically backed up. That means it will be kept somewhere else, and this is how the backups are done. So usually if you have an application, let's say you have a finance application, in that finance application there are going to be 2500 tables. Huge application, SAP, ERP, Oracle apps, they have their applications and their apps will have thousands of tables. So what will happen, there will be a user created, and that user's name is going to be, let's say, financial application. The user's name is going to be Fin, F-I-N. This user is going to have all its 2500 tables over here, but that user will be created in such a way that his default table space is going to be TS1. Or maybe they will give a different name. They will give the name as Fin Data, financial data. That is the name of the table space. 1 gigabyte is reserved, or 1 gigabyte is created, and now all the tables of Fin will be now created in this table space, and they will not assign this table space to anybody else. They will not assign this Fin data table space to any other user. And then what will happen? If I say please take a backup of the Fin schema, they will just go and they will take a backup of this table space, and the backup will be done. This is how typically things will work in the industry. Now when this table space is totally full, what to do? They can increase the size of the table space. Okay, those are all the other things that will happen over there. It can also happen like this, that this is one table space and then this is another table space. This user Fin will create half of the tables over here and half of the tables over here. Important tables here, not so important tables over here. Why? Because important tables should be backed up maybe every night. Not so important tables where data doesn't change, that should be backed up once a month. So all that can be done when the user is created. This is the default table space, this is a non-default table space. Non-default table space, a table can be created in a non-default table space by specifying the table space name. If you don't specify this clause during the table creation, if you don't specify table space is equal to TS1, where will the table be created? In your default table space, which has been assigned to you during the creation of the user. But when you do specify this clause, it will get created in any table space where you have quota assigned. Okay, so it is not, yesterday we did not go into too much of details about this thing. We just said there is a default table space for a user and then the quota is assigned. Default table space is just one table space where the table will be created if you do not specify this table space clause during the table creation. But non-default table space is the table space in which you can create the table because you have quota assigned to it. Okay, certain quota assigned to it. So this is how you specify the table space parameter. So this is how it could happen. The main point that I would like to emphasize is that yes, there are extents, then inside extent there are blocks, and inside blocks there are rows. So let me kind of this was my goal, to kind of fit into our logical view into this physical view. Actually we see that I am logged into the Fin schema and I am working on this table, but my tables could be sitting right next to your tables as far as the placement of the table on the disk is concerned. So logical view, this is something on the disk side. Now so let me summarize this thing. So summary is like this. So there is a, at the very top level, there is a table space. Okay. Inside the table space, what is there? There are extents. Or inside the table space, there are tables. Okay. Inside the table space, there are tables. So one table space will have multiple tables. So this is one-to-many relationship, you can say. I'm not really drawing a data model, but just I'm trying to kind of explain the concepts here. Within one table space, there are multiple tables. Now, there is an extent. What is an extent? Extent is basically an area on the disk, on the hard disk, and multiple extents will create one table. Multiple extents will create one table. Within the extents, there are blocks. Those are DB blocks. And within one extent, there would be multiple database blocks. And within each database block, there would be multiple rows. And how many rows? Depending on the size of the row for that table. So this is what a typical structure is for any table spaces.
But through this table space theory, lots of memory wastage.
Lots of hard disk is, I wouldn't say wasted, but it is reserved. For example, that 1 gigabyte disk space that we have reserved, unless and until we create tables in that 1 gigabyte, that is all reserved for that TS1. No data is there inside that 1 gigabyte table space, but yes, it is reserved for that table space. This is where the capacity planning comes in. You have to find out how much of growth are we going to have. You have to find out how big that fin schema is going to be. How many tables, what are going to be their sizes, and based on that you create a table space.
Based on that we have to assign the blocks actually.
No, not blocks. No. Size of the block is, a decision of the size of the block is little different matter. So we'll talk about that. By default you should go with the 8K size. But smaller the size, the better the performance in certain situations. Larger the size, better the performance in some other situations. And we will talk about those situations later. But right now, just think that when you are going to create a database, we'll be creating a database maybe in a couple of days. At that time, you should decide the size of the database block should be 8K. Because you don't know whether that will increase the performance or decrease the performance. There are certain very specific situations where the size of the data block should be used or should be changed. But this is what the whole thing is. So we'll take a kind of a break.